That is the lowest term it can go. While molecular formula, it is the actual formula that represents the number of atoms present in one mole of a compound. The difference between empirical formula and molecular formula is that the empirical formula is the simplest formula, while the molecular formula is the actual formula. There is a relationship between empirical and molecular formula, and that is shown below. Empirical formula denoted by EF is equal to molecular mass all into N. Example: ethane. Empirical formula of ethane is CH3, while the molecular formula is C2H6. From the above, it can be shown that empirical formula is the simplest formula because this 2 has been reduced, has been divided by 2. 2 divided by 2 gives 1 atom of carbon. 2 divided by 6 gives 3 atoms of hydrogen. This is the simplest formula that this can undergo. While the actual formula of this particular compound, ethane, is C2H6. So this is the difference between empirical formula and molecular formula. Laws of chemical combination. The first one is law of conservation of matter. This law states that matter can neither be created nor destroyed during the course of a chemical reaction, but changes from one form to another. A typical example of that is sodium in the solid state combined with chlorine half mole in the gaseous state to give you sodium chloride in a solid state. Here, sodium is created and it is not destroyed because you still have it in the product. Chlorine is created and is not destroyed because you still have it in the product. So this justifies the claim that matter can neither be created nor destroyed, but changes from one form to another. Law of constant composition. It states that all pure samples of a particular chemical compound contain similar elements combined in the same proportion by mass. Here, a compound is splitted into its constituent elements. And a typical example of this is copper 2 oxide. Here, copper 2 oxide is splitted into copper 2 plus O2. So this reaction has justified the law of constant composition, where you have a particular compound being broken into its constituent elements. And this law of constant composition is also known as law of definite proportion. Another name for law of constant composition is law of definite proportion. The last one here is the law of multiple proportion. It states that if two elements, A and B, combine to form more than one chemical compound, then the various masses of the element A, which combine separately with a fixed mass of the element B, are a simple multiple ratio. What it means is that copper, solid, coming together to react with oxygen. Oxygen has two atoms here. Copper is of 2 moles to give you copper 2 oxide. Here, 2 elements come together to form a compound. So this one is representing A, while this is representing B, and it gives you AB. So 2 constituent elements coming together to form a compound. That is what the law of multiple proportion is talking about. Chemical equations. Chemical equations are the interplay between reactants and products. What you have on the left-hand side of the equation is reactant. What you have on the right-hand side of the equation is products. The right-hand side of the equation is where product reappears, while the left-hand side of the equation is where reactant diminishes. The reaction between magnesium and hydrochloric acid is one example. The second example is the reaction between copper and hydrochloric acid. In the reaction between magnesium and hydrochloric acid, here magnesium Mg reacts with hydrochloric acid, which is 2HCl, to give you magnesium chloride, MgCl2, plus hydrogen gas. What ensures the feasibility of this reaction is because magnesium is higher than hydrogen in the electrochemical series, making it more reactive than hydrogen. That is why it is able to displace hydrogen from hydrochloric acid. Reaction of copper with hydrochloric acid is not feasible. Why? Because copper is lower than hydrogen in the electrochemical series. Therefore, this copper will not be able to displace hydrogen from its compound. So this reaction will not occur. The following are the questions Design for the above topic. Question 1. What is the atomicity of ozone? Question 2. A molecule of neon is A. diatomic, B. ionic, C. triatomic, D. monoatomic. Number 3. State the law of definite proportion. Number 4. From the equation of reaction in which 2 moles of hydrogen gas react with 1 mole of oxygen gas to produce 2 moles of steam, calculate the number of moles of oxygen gas required to yield 6 moles of water. Number 5. If the relative molecular mass of CH2O is 60, calculate the whole number of atoms where carbon is equal to 12, hydrogen is equal to 1, oxygen is equal to 16. The following are the solutions to these questions. Number 1. What is the atomicity of ozone? Ozone has a formula O3. From this formula, atomicity is the number of atoms present in 1 mole of an element. And if you look at what you have here, you will see that you have 3 atoms of this particular element, oxygen, making it ozone. So, therefore, the answer to question 1 is 3, because